Now that we have made up our approximately 0.1 molar sodium hydroxide solution, we're going to move on to the primary standard portion of the lab. So as you'll notice today, I'm in front of a different balance, and what this is an analytical balance. So normally our balances go out to 1 milligram or 3 decimal places with respect to the gram. So this goes out to 4 decimal places or 0.1 milligrams. Okay, so 4 decimal places here. So in addition to it being much more accurate, it's also much more expensive. So it's 10 times more accurate, right? It goes from 1 milligram, which we have in the teaching lab, to 0.1 milligram. That's an order of magnitude difference. Well, this is an order of magnitude more expensive. So this is about a $6,000 balance. Some of the features of this balance is it has draft shields. These are glass doors that prevent any drafts from my breath or atmospheric climate control, things like that, causing that balance mass to drift. It's got some wheels on the side that allow me to level the balance, and there's a leveling bubble on the back, much like a construction carpenter's level. And so this is very precisely leveled. Next, it's on a very heavy duty, very heavy reinforced marble-like table that itself cannot vibrate. And the reason I would want that is this balance is so accurate that lawnmowers, trucks, and stuff like that could actually vibrate this room such that I would be able to see it on the balance. But given that I've got this reinforced table, that can't happen. Finally, this balance has an internal calibration mechanism, so it goes through a self-calibration every few hours when it's on. So it does that. That makes it a lot more expensive. And finally, we double check that calibration every so often with a calibration weight. Now, this calibration weight is certified by the National Institute for Standards and Technology, and it's very expensive little weight. The balance is so accurate that by touching the weight with my fingers without using these tweezers, I would actually change the mass of this little weight. So we only ever touch those with these tweezers, and then it goes back inside this nice little carrying thing here. So that's a little bit about the balance. Now the next thing is our primary standard. So today for our primary standard, we're going to use KHP, or potassium hydrogen phthalate, and it's got a structure that looks like this. It's got a molecular mass at 204.23, so that's 204.23 grams per mole. And the powder or crystal looks like this. It's extremely pure. That's what you want in a primary standard. You want it to be very pure, because if it's extremely pure, nothing else is in there that may or may not react with what I'm titrating against the sodium hydroxide. And as you can see on the bottle here, it's accurate. It says ACS certified 99.95 to 100% pure powder. Okay, white crystalline powder. So this stuff is as pure as you can get. Some other features: you want your primary standard to be soluble in water. We're going to be doing our titration aqueous, so it's soluble in water. You want it to be stable. And then very importantly, you want the primary standard to be not hygroscopic. So this stuff does not take up moisture from the air, unlike this sodium hydroxide from before. If you remember that sodium hydroxide, as soon as I opened it up, the mass started to change because it would take up moisture from the air. This does not. So you want your primary standard to be not hygroscopic. So it's not hygroscopic, this stuff. When I weigh it, the mass will stay that way. Whatever I put in here, the mass will not change from atmospheric moisture going in to change that mass. Finally, it will react rapidly with our sodium hydroxide. So there, we've covered a little bit about the balance room, and some features of primary standards. Now I'm going to go ahead and begin by, I've got 3 trials available here, 3 Erlenmeyers, which I've labeled already, and I've got a little note sheet here. So I'm going to open up my balance door and carefully take the mass of the first Erlenmeyer, (93.0208). So 93.0208 grams. And now I'm going to add approximately a half a gram of KHP to this. So again, this will give me my gross mass, and you'll get to take the difference between what I read here and the empty mass of the Erlenmeyer to get my mass of KHP. So the gross mass of the KHP plus the Erlenmeyer is 93.5298. Okay, so we've got our data for trial 1. Now we've got trial 2. I want to make sure I get that balance teared out. Make sure I get that as zeroed. There we go. We've got it teared out now. And record the empty mass of our second Erlenmeyer as 92.7806 grams. So that's that. Then I'm going to take my next aliquot of KHP, carefully add this like so, get the gross mass for trial 2 as 93.2851 grams gross mass. So again, the difference between this mass and the empty mass of this Erlenmeyer is the mass of the KHP. Finally, make sure I get this zeroed again. I got a nice 0 there. The empty mass for trial 3's Erlenmeyer is 94.7295 grams. All right. Now I'm going to add my last approximately 5 grams of KHP to this one. Close that draft shield. Let's balance stabilize and get 95.2220 grams. And again, the difference between this mass and the empty mass of the Erlenmeyer is the mass of the KHP. And now I've got those 3. The next thing I want to do is scoot the camera over just a little bit. Clear away some of this. Now to each of these 3 Erlenmeyers, I am going to add 100 milliliters about of water. And this is distilled deionized high purity water here. It just has to be DI water. There we go. So I'm going to give them each a little swirl. And in some time, all of this KHP will dissolve. Finally, I'm going to add 2 drops of phenolphthalein to each flask. And this is the indicator. So once this stuff becomes basic, it'll turn pink. So there we have our 3 samples ready for titration. And the last thing I'm going to do is I'm going to put a little bit of this stuff called parafilm. This stuff is wonderful in a lab. Rather than using rubber stoppers or anything, I've got this, it's like saran wrap, but it's a great polymer that wraps around the top so that I don't lose anything there, like that. So this stuff's called parafilm, so I parafilm the top. Basically lab saran wrap, but better. And boom, there are my 3 primary standards ready to go for titration against sodium hydroxide. We'll see you in the next portion of the video.